Good evening, Titans. This is Mr. Simpson, and tonight we're going to begin Chapter 8. And in Chapter 8, we're going to be graphing quadratic functions and graphing them in the form a times x squared. The essential question is, what are some of the characteristics of the graph of a quadratic function of the form f of x equals a times x squared? Here's the vocabulary. So if you open your student journal to this page in lesson 8.1, you can write down these vocabulary. Again, we'll go through these throughout this video. Again, the quadratic function is in the form y equals ax squared plus bx plus c. The parabola is the U shape, and again, we've done this a couple times. You've seen it on Desmos. It looks like that. The vertex will be this point right down here, and the axis of symmetry is this imaginary line that cuts the parabola right in half, where if you would fold it on that line of symmetry, the two halves would match up, which will help us when we're having to graph them. And also that the axis of symmetry passes through that vertex point. Alright, first of all, a couple characteristics of quadratic function. Again, it's a U-shaped graph. The lowest point of the graph is called the vertex. Now, parabolas can look like this, and so then the vertex would be up here, and they can open up like that one. Now, as the graph is going from left to right, this part is going down. The y values are decreasing as the x values increase. We call that a decreasing function. And then at the vertex, it changes and becomes an increasing function as x gets larger, meaning y gets larger. And again, that axis of symmetry is that line right down the center of the parabola. So if we're looking at this particular parabola and we're asked to identify the characteristics of it, well, first of all, we could identify the vertex. The vertex is this point right down here, okay? And that vertex is the point at -1, -2. And we could say that it opens up. We could say that the line of symmetry happens at x equals a -1. Again, the line of symmetry will always be x equals the x value of your vertex. We could say that the domain are all real numbers, which for parabolas will be all real numbers. And then the range, which are the y values. Again, remember, the domain are the x values, the range are the y values. The y values only go from y is greater than or equal to a -2, because that's where the graph is going up, right? And then, again, it's a decreasing function from up until x equals a -1, and after x equals a -1, then it's an increasing function. So if we're identifying characteristics here in number 1, first of all, I'd identify the vertex. The vertex would occur at 2, -3. The line of symmetry would be at x equals 2. I'd say the domain is all reals. I'd say the range is y is greater than or equal to a -3. And it's a decreasing function up until x equals 2, and then it's an increasing function as x is greater than 2. Also, it opens up. Number 2, my vertex, it appears, is at 2, 7. So that means my line of symmetry would be at, that's -2, 7. My line of symmetry would be at x equals a -2. And here my domain, again, is all reals. And then my range would be the values of y is less than or equal to that y coordinate of my vertex. And then it opens down, which means it's actually an increasing function up until that value of x equals a -2. And then it's a decreasing function after that. Now, here we're going to look at if I have y equals a times x squared. Now remember, just x squared is the very first problem that we looked at. It has a vertex right here at 0, 0. And if I plug 1 in, 1 squared is 1. If I plug 2 in, 2 squared is 4. And then because it's symmetrical, I know that these points over here, and now I have that graph. And this is just y equals x squared. Well, if we're going to multiply the x squared times a number out in front, let's see what happens to it. And so it says if a is less than 1, meaning if the value of a is less than 1 but greater than 0, so that would be a fraction or a decimal, it looks like it's going to be wider. It's going to make the graph wider than the parent graph. And if that a is greater than 1, then it's going to make it narrower. So the green is the narrower graph. Now, if the a is negative, then it makes the graph open down. Okay, it's reflected over the x-axis and it opens down. But again, if we think about the negative is just reflecting, then if the value of a, the absolute value of a, is between 0 and 1, then it's going to be wider. And if it's greater than 1, then it's going to be narrower. So now I want us to graph this. So I have 2 rows here, and typically I wouldn't do this, but just to show, if we're going to graph this first one right here, and I plug 0 in for x, 0 squared is 0 times 2 is 0. Plug 1 in, 1 squared is 1 times 2 is 2. When I plug 2 in, 2 squared is 4 times 2 is 8. I plug 3 in, 3 squared is 9, and 2 times 9 is 18. And then I go ahead and I try to graph this. So looking at my graph, I'd put a dot at 0, 0. Then I'd have one at 1, 2. One at 2, 4. And then, 2, 8. Okay. Sorry, not that one there. And now, and I don't have room to put the 3, 18. Okay, again, this is my x value, this is the y value. Then I'm just going to do the points that are symmetric. So I go 1 over, 2 up, and I go 2 over, and 8 up. And now I graph my parabola. And notice how it's skinnier or narrower than the parent graph. Now if I do this other one, and this time here, let me erase this stuff here real quick. Now I plug 0 in. 0 squared is 0, and 0 times a negative 1/3 is 0. I plug 1 in. 1 squared is 1, and 1 times negative 1/3 is negative 1/3. 2 squared is 4, and 4 times negative 1/3 is negative 4/3. And then 3 squared is 9, and 9 times negative 1/3 is a negative 3. And now I graph these. So again, I have the point 0, 0. Then I have 1, negative 1/3. I have 2, negative 4/3. That's just past a negative 1. And then I have 3, negative 3. And again, I do the symmetry. So 3 away here and here. And so as you can tell, this graph would be wider than the parent graph. And I know my graphs are kind of small here, but if you plot these ordered pairs on your graph here, you'll be able to get those figured out. Alright, in this diagram it says, the diagram at left shows the cross-section of a satellite dish where x and y are measured in meters. Find the width and depth of the dish. Well, if we look at the ordered pairs here, this goes from negative 2, 1 to 2, 1. Well, so the width goes from negative 2 to 2, so the width is 4 meters. And since the vertex is at 0, 0, it's 4 meters wide and 1 meter deep. All right? Okay, I'd like you to open your book to page 248, your student journal, and work problems 1, 3, and 5. And if you don't have a student journal and this is what you're using, you can just put your graph or do these 3 problems right here. Have a great evening, Titans, and we'll see you tomorrow in class.